Hey, welcome back. We're here now on to section 1.1. We're going to be analyzing categorical data. That's what we're going to be looking at. Now, again, the learning targets that we have, what we should be able to do is to make and interpret bar graphs for categorical data. Identify what makes some graphs of categorical data misleading. We'll talk about that. And then we're going to calculate marginal and joint relative frequencies from a two-way table. We're going to calculate conditional relative frequencies from a two-way table. And then we're going to use bar graphs to compare distributions and then describe the nature of the association between two categorical variables. And we're going to split this up into two parts. So we'll do a 1.1a video that'll take us through the first 22 slides, and then we'll go through a 1.1b video so as we go 2 different days. I don't want to throw too much at you and overload you, so that's kind of where we're at. All right, so as we're looking at here, let's just pick something out here. We've got some, obviously some data here in a distribution, and we're going to look at one of the categorical variables, which is preferred communication. So things there could be in person, Facebook, cell phone, text messaging, those types of things. So those are the data that we're talking about right there. All right, so if we do a frequency table, now notice the difference between the two. What we kind of go back and forth on is we go through and we count up. All right, so how many do we have from cell phone? If you go back there, you can see that there's 2, and that if you go to Facebook, there's only 1 person that shows Facebook. Must be some boomer, as they call it, some old guy like myself. I don't know. That's probably not my preference, but and then we have those. So again, when you add up those frequencies, make sure that those add up to how many things that you have. So make sure that you don't miss one. All right, so now that's just the frequency table, but if we want to have a relative frequency table, we want to convert those into percentages, proportions, and that way it has a relative, it has a relative relationship that we can pick out. So that way the number of sample data that we have isn't going to really be misleading in some sort. So we're going to have that percentage. So just take those, 2 divided by the total of 10, and so we get all those. And again, when we add up all those, it should be 100%, and they are. All right, so now, again, we can display the data. A good way is to use a bar graph, and there we go. We just changed that into a bar graph. Now, notice a couple things that we have here, and we have the percent. That's always a good thing to use for this. You can see that the cell phone was at 20%, the Facebook is at 10, in-person is at 30 and 40, and it gives you a nice look to see how they relate. Now again, some key things when you make this is that it's always a good idea to start at 0, okay? And then make sure we're going equal increments up here. Sometimes it's appropriate to do 10s, maybe 5s, depending on what your data is. And you want to have a nice little, and make sure that we're labeling those. So that's very easy to see. Very nice way of displaying the data with a bar graph. Now we can also use a pie chart, and again that's based on the percentages. So by using those relative frequencies and percentages, we can break that up. Now remember, there's 360 degrees in a circle, so when we're talking about 10%, that should be about 36 degrees, right? So you can convert those to degrees as we have those. Again, pie charts are great when you have data that's relative and that it adds up to 100%. That's kind of a good way of doing that. So a couple different ways that you can get an idea of what's going on, okay, displaying that data. All right, now sometimes they say, all right, bar graphs, and pie chart looks pretty good. Some people do this, they use like some pictures. And sometimes those pictures can be really misleading because right now it looks like Macintosh is like huge over Windows and none in the example that we have here, and that's because we're displaying things that have multiple dimensions here. So make sure that the area, if this, right now, this is about 3.5 times bigger than that, but it sure looks a lot bigger. So I kind of warn yourselves away because it's the area that you want to have 3.5 times bigger if you're picturing that up. It's just kind of a misleading way of doing it. So picture graphs kind of, maybe shy away from. Again, the scales can really be misleading, and that's something to look at when you're looking at data on your own. All right, so how do you analyze data when the data involves 2 categorical variables? So we're going to talk about a two-way table. And it's a way to kind of put 2 things on there, and it's kind of nice where you can summarize those up. So now we can kind of do things here where we have environmental club member or snowmobile, and then there's snowmobile use. So we can kind of compare those 2 things, and we can do some totals here. So we can just add up the rows and the columns, and you've got some totals to look at here. So you can kind of compare the two variables. So again, two-way table. It's going to kind of summarize data on the relationship between 2 variables, and we're going to be able to use that as we look at some things. So A marginal relative frequency gives the percent or proportion of individuals that has a specific value for one categorical variable. So here's an example. How many people said no? All right, well, as we look there, yeah, there was a total of 1,221 people said no out of the total of 1526. So what we can do is say, oh, that's 0.80, that's the proportion of, or 80%. All right, so what about yes? Well, that's 305 as we have those totals out of the 1526. That's 20%. So that's a marginal relative frequency. Again, giving the percent, the proportion is the 0.200, so depending which way you give it. There you go. Now again, some other ones you could say, well, what's the marginal relative frequency of those that are never? Well, okay, add them up, 657 out of the 1526, and then of course you can have the ones that that rent, of course, and then of course you can have the ones that own. So kind of nice when you have that two-way table of kind of summing up those columns and rows, and then you can get those marginal relative frequencies rather easily. All right, now again, a marginal relative frequency tells you only about one of the variables. Okay, so only tells you about one in the two-way table. All right, now a joint relative frequency, not a marginal relative frequency, but a joint, can give you the percent or proportion of individuals that have a specific value for one categorical variable and a specific value for another. Okay, so again, joint meaning a couple of them as we put them together. So it kind of helps us answer questions involving both of the variables in a two-way table. So here's an example. What percent of people in the sample are environmental club members and own snowmobiles? Okay, so let's see if we can find that. Where's that total on here? Well, if we take a look, yeah, we've got environmental club here and own snowmobiles. That's only 16 out of the 1,526. Okay, so that would be a joint relative frequency. Again, it would be 0.01 or as a percentage 1.0%. And again, usually good to include those decimals in there. All right, how about another one here? What proportion of people in the sample are not environmental club and never use snowmobile? Okay, so let's see if we highlight that correctly here. All right, let's see the next thing that we have. Yeah, it's the 445 out of the 1526. So that's, as we look at that, that's 0.292 or about 29.2% is what we have. All right. Well, there we go, guys. That's going to leave us up to where we need to get through today. We're going to cut that off, and we'll pick up next time with the second half of 1.1. We'll call it 1.1b. That should be enough to get you going on today's assignment. We have plenty for you to do today. All right. With that, I'm Mr. Boone. See you next time.